All right, guys, we're gonna finally be going over homework 8 here. As you can see, I got a little bit of an accident in the kitchen the other day, so my handwriting is not good at the best of times. It's not gonna be good at all now. So unfortunately, it is what it is. Bear with me. I'm probably gonna have to scribble things out and rewrite them if I end up not writing it in a clean way the first time. But luckily, this homework is not too heavy, I don't think. And again, it's gonna slow me down as well, so you might wanna bump the speed up on this one. Homework 8 is exponents and exponent rules. Now we've already talked about it. Well, we haven't talked about it, but you've seen exponents in a couple of the homework problems. I think they just popped up here and there. You're probably already familiar with what we're talking about here. Something that looks like this, right? Remember, A and B can be whatever letters you want them to be. The A here is called the base, and the B is the exponent or the power. Okay, so just the terminology. If I say the word exponent, if I say the word power, it's the same thing. It's A raised up to the B, right? And you guys know what this means. If I had 4 raised up to the third, it's 4 times itself 3 times, right? 4 times itself 3 times. Not 4 times 3. If we wanted 4 times 3, we would write 4 times 3. So 4 to the third, 4 times 4 times 4. 4 times 4 is 16. Times 4 is 64, right? So just the basics. You guys probably already knew that stuff. You know what an exponent is. Let's go over some of the things that you may or may not be familiar with about exponents, just to make sure we're all clear. Anything to the 0, and again, I'm using A for anything. You can put any number you want in there. Anything to the 0 is 1. This is one of those things I might go off about a little bit more in a traditional class. But in an online class, I like to stick to just what you guys need to know and not try to fill it with extra things. I don't want to confuse anybody. So we'll leave it at that. If you have any interest in the question, let me know and I can try to explain this to you. But anything to the 0 is 1. It is not 0. You cannot get 0 with exponents in any circumstance in this class. If you ever get 0 as an exponent answer, it's not correct. You could have a 0 exponent, but again, that does not make 0. It makes 1. What if I took anything and raised it to the first power? Well, that would be just that same thing back, okay? So let's do an example here with numbers. If I said I had 6 to the 0, that's 1, okay? If I had 6 to the first, that's just the same thing back, that's just 6. So recognize a couple of things here. First of all, again, you do not get 0 from a 0 power. First of all, very important. Second of all, anything to the first is itself. 6 to the first is 6. And it goes the other way as well, yeah? 6 is the same thing as 6 to the first. So if you see just a regular number, you can say, well, there is a power here. The power is 1, okay? Whether it's written or not. So that's great, that's cool. That's what exponents are, no big deal. And a little bit of your homework will just be some practice with stuff like, 4 to the third, 3 to the 7, stuff like that. If it is a number, you are expected to work it out and go ahead and go out all the way with it. Same on the test. Couple of things here. I guess we'll just go ahead and get another sheet of paper. I need to be lazy about this. Couple of things here. First of all, when negatives are involved, it's a little bit more complicated. So take a look at those two expressions, right? They're expressions because they don't have equal signs. -2 squared versus -2 squared. You say them the same way, so are they the same thing? The answer is no. And if you put these in a calculator, you're going to get 2 different answers. And a lot of times students will come up to me and they'll say, well, my calculator said that -2 squared is wrong. It's -4. Well, first of all, calculators don't just get math wrong. It doesn't work like that, right? The calculator is going to make a mistake. It's just going to start spitting out gibberish. It's not just going to give you the wrong answer. The calculator is not wrong. That is -4. And this one here is what they're thinking it should be, -2 squared, which is +4. But unfortunately, when you say them, it doesn't differentiate because they say the same way. Both of them are said the same way. What's happening here is the negative being applied in a different way. So on the -2 squared, where the negative is in parentheses, this is what most people think of when they think of -2 squared. It's -2 times -2, which is 4, right? The negative was included, and we know that because of the parentheses. It's kind of a weird thing to say, but think about these as like somebody putting their arms around someone, right? Those two people would then be associated together. I realize I'm blocking this with the finger here. -2 is negative is associated with the 2 because they're both in parentheses. Over here, the negative is not associated with the 2. If I wanted the negative and the 2 to be together, I'd put them in parentheses. So for exponents, if there's no parenthesis, that negative is not included. So what this would look like is you just have the negative sitting there, and then you have 2 squared. 2 times 2, which is -4, okay? Take a minute, make sure you're clear on this. This is something that gives a lot of people fits, and even our calculus students will come to us, you know, with a page-long equation saying something's wrong, and then you end up looking and it's something, you know, like a triviality like that. If you put this into a calculator, which you guys shouldn't be doing because there's no calculators in the class, but if you put this in a calculator, we'll give you -4, and that is not an error. What if I said -3 to the third versus -3 to the third? Same question, right? 1 in parentheses, 1 outside the parentheses. That's to the third. That doesn't look any better, does it? -3 to the third. It's the same thing. So are they going to be different or are they going to be the same? Well, this time they're going to be the same, and you just need to work it out. This one, the negative is associated with the 3. Think about the associative property, right? That was the one that had the parentheses. The negative is associated with the 3 because they're in parentheses. So this is -3 times -3 times -3, which is negative, 27. This one over here, the negative and the 3 are not associated together, right? I gotta watch what I'm doing here. Sorry, that's blocking everything. The negative and the 3 are not associated together. If they were, we'd have them in parentheses, just like we did there. So here, the 3 is raised to the 3rd power, 3 times 3 times 3. And the negative is just sitting there. So in this case, 3 times 3 times 3 is 27, and the negative is still there. So sometimes they are the same, and sometimes they are not. It is possible to just memorize. It has to do with the power being even or odd, or if the negative is in the parenthesis and out of the parenthesis. But then you're talking like 4, 6, 8 different combinations to remember. To me, and this is what I say to my classes, it's always easier just to break it down. -2, negative is in parentheses, so it will be used. -2 and -2. Here, the negative is not in the parentheses, so it would just sit on the outside, right? That's the way I would tell you to do it. Write it out, break it down, show what's happening, and you're going to get it right every time, okay? The only issue is with the 0 power, right? That's when the breakdown doesn't really work. So if I asked you, -7 to the 0 versus -7 to the 0, okay? You know that the answer is 1 or -1 because we already said anything to the 0 is 1, and so the answer is 1 or -1. It just depends on where the negative is, right? Well, over here, think about it. Take a minute, think about it before you look at the answer. Pause it if you need to. Here, what is being raised to the 0 power? Everything in the parenthesis, right? -7, negative and 7 are included. Everything to the 0 power, anything to the 0 power is 1. And they're included because they're next to each other. Over here, the negative and the 7 are not related because they're not in the parentheses. So it's 7 to the 0, which is 1, and the negative comes down. So if I was going to give you a shortcut to this, and this is not the be-all, end-all, I would say the following. Notice that the one where the negative is not in the parenthesis, it always is in the answer, right? Negative not in the parenthesis, negative in the answer. Negative not inside the parenthesis, negative in the answer. Negative not inside the parenthesis, negative in the answer. If it's not inside the parenthesis, it's going to be in the answer. If it's in the parenthesis, it may be in the answer or it may not be. It depends on how many times there was a negative, right? In this case, there was 2, negative and negative is positive. In this case, there was 3, negative, negative, and negative is negative. In this case, there, I mean, you could say almost the negative got canceled out by the 0 to make 1. So just be careful. Negatives, or the negatives in the exponents cause a lot of trouble for people. Again, even higher level students will forget this kind of stuff, and it'll cause them problems down the road. So this is something to spend some time on. Even though it seems like it's a triviality, it's actually probably the part of the homework that's going to stick you more than anything else. It's just these negatives. So watch out, okay? And be careful because partial credit is really not going to be available here, right? Because if I give you this question, well, you know it's 1 or -1, and so you could guess, and we can't give partial credit on questions that have a 50-50 outcome. So study up on the negatives with the exponents. Make sure you're comfortable with that, okay? We're going to go into the exponent rules next. There's 3 of them, product, power, and quotient rule. We'll go through each one with examples. But just kind of, this is the general overview for exponents. Now we're going to go into exponents and combining them, okay? So take a minute, make sure you're clear, and we will go from there. All right, let's move on. So like I said, there's 3 rules to the exponents. I mean, there's obviously many rules to exponents, but there's 3 main rules to exponents in terms of combining them, okay? So we'll start with the first rule. This one is called the product rule, and the name is important. Well, we'll talk about why in just a minute. I want to jump the gun. Product rule. All right. Product rule. Think about what product means. It means to multiply, right? Be careful about that. You are going to multiply in a way. You'll see what I mean in a second. So you can do this with numbers or variables. So we could say the product rule says the following. If you multiply two bases, let's say 2 squared times 2 to the 5th, what will happen is the powers are going to add. And that's what the rule says. If you have 2 to the 2nd times 2 to the 5th, what you really have is 2 to the 2 plus 5, 2 to the 7th. You don't need to write this step here where they're adding together every time. I'm just showing you what's happening. And what I meant when I said a minute ago we can do this with variables, and we mostly will. For the most part, I'm going to use variables here because they could just represent anything. If we had x to the 3rd times x to the 7th, that would be x to the 3 plus 7, that would be x to the 10. And that's what the product rule says. It says when you multiply the exponents, you should, or when you multiply, you add exponents. Now, notice the bases have to be the same, x and x, 2 and 2. If they were different bases, they're not going to combine and you just have to treat them separately. The reason, for the most part, I'm not going to do the numbers is because with the numbers, you don't really have to do this. You could just say, oh, well, 2 squared is 4, and 2 to the 5th is 32, and 4 times 32 is this. And then you have the answer. There's no need to combine the powers because you can just work the numbers out. This is really more important when you have variables, when you don't know what x is. So there's no way for me to work out x to the 3rd or x to the 7th. All I can do is combine them down to make it simpler. And that is really what we're doing here, is simplifying, okay? You'll see the instructions. A lot of times we'll just say simplify. So again, you can do this with regular numbers. I'm not going to do it frequently because most people won't. They would just work the number out, and then multiply to get whatever they get. With variables, that's really more where we're concerned. Okay, so this is the product rule. Now think about what I said a minute ago when I said, what does product mean? It means to multiply, right? Well, are you multiplying to get this 10? No, you added the 3 and the 7 to make the 10. So this name can throw people off. The name is not telling you what the rule does. The name is telling you when to use it. When do you use the product rule? When you're multiplying. What does the product rule actually tell you to do? Add the powers. If you have trouble remembering this, you can do this, although on the test you might run out of time because these numbers can get big. Think about what x to the 3rd means. It's x times x times x, right? And x to the 7th is 1, 2, 3, 4, 5, 6, 7 x's, right? And they're all multiplied. Well, how many do you have in total? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? We're just saying I have 3 x's times each other, and then another 7 x's times each other, and that makes 10 x's times each other. You don't want to do this, though, because if I gave you, a to the 27 times a to the 13, you don't want to have to write out 40 a's. You know what I mean? So you want to be able, these are really shortcuts to avoid you having to do this. But if you had to, I guess you could write out 27 a's, 13 a's, add them all up and get 40. That just seems to me like a lot of work. So we use the product rule, which tells you when to use it. The name tells you when to use it. When you're multiplying them, you use this rule, which actually tells you to add the powers. So you can already see where confusion could come in if you don't spend enough time with this. Now, the other thing about the product rule is it's not usually this simple. You got to be careful. A lot of the problems in the homework are very, very trivial. And then all of a sudden, they'll dump like a much harder problem on you out of nowhere. So next week down the road, I'll send out a worksheet to give you an idea of stuff you'll see on the test. But for now, they might have silly little ones like this. Oh, 3 plus 7, that's 10. They might step it up on you like this. So we have 3a to the 4th times a to the 5th. A to the 4th and a to the 5th, that's 9 a's, right? 4 a's and 5 a's, that's 9 a's. And then 3, well, what number would be in front of this a to the 5th? When we put a 1 there, we don't write it, but it's there. 1 times 3 is just 3, all right? No big deal. Step it up just a little bit more. And this is going to look a lot crazier, but it really isn't. You're going to see once we're done with this. I just went through and did each one separately. So this is, about as ugly as you can expect the product rule to look here. Another one. We have negative 2x to the 3rd, y to the 5th, times 3x to the 4th, y to the 9th, z squared. So what I would do is just take each one of these and go separately, right? We have 3x's and 4x's. So we have 7 x's. I like to mark them off just so I don't forget about them. We have 5 y's, we have 9 y's, 5 and 9. Remember, the product rule tells you to add the powers, so we're gonna have 14 y's. We have no z's at all here, we have 2 here, so just 2 z's in total. And then now here's the trick, and this is the part people miss. If you had to guess which part people miss more, the number, the x, the y, or the z, you'd be correct if you said the number, because they say, well, -2 + 3, that's 1. These are exponent rules, right? This is an exponent rule. What do you do with the powers? What do you do with the exponents? -2 and 3 are not exponents. Those are what we call coefficients, just the numbers in front. So -2 × 3 is -6, just like it always has been. So be careful. These rules apply to the exponents only. They do not apply to the regular whole numbers. Be careful about that. So take a minute, go back through that, see that it makes sense to you. -2 × 3 is -6. Those are just regular numbers multiplying. And then we added 3 x's to 4 x's to get 7 x's, 5 y's to 9 y's to get 14 y's. And then the 2 z's didn't have anyone to pair off with, so they just came to the answer. So that's the product rule. It just says when you're multiplying, add the powers. Whether there's a bunch of different things or just 2 things, it doesn't matter. The rule's the same. When you're multiplying exponents, you add the powers of the exponents that are similar, okay? So that's one of the rules. The other rule, or one of the other rules, and I guess you could say the sister rule to the product rule. Well, here, you could probably figure this out before I even tell you. Think about what I'm saying here. If the product rule tells us to add when we multiply the powers, right? The product rule says when you multiply powers, you're gonna add them. What do you think would happen if we divided the powers? If we multiply them and it makes us add, what would happen when we divide? Probably subtract, yeah? That's exactly what's gonna happen. The second rule, and I hope I spelled this correctly, probably should have written it down first, is the quotient rule. Quotient rule. Quotient means to divide, all right? So what this says, similar to the last problem, if we had a to the 8 over a to the 5th, it's similar, I guess, but actually different. You know, we're not adding anymore. We're going to what? Subtract, right? Because there's 8 a's on top, 5 on the bottom. They're going to cancel out, and there'd be a to the 8 minus 5, a to the 3rd. Again, you don't need to write this middle step here. I'm just showing you what's happening, okay? So that's what quotient rule says. And again, think about it. It makes sense, right? You have 1, 2, 3, 4, 5, 6, 7, 8 a's over 1, 2, 3, 4, 5 a's. The same problem we just did. And then they're going to cancel. 2, 3, 4, 5. How many do you have left? You had 3 a's up at the top, didn't you? This is where you have to be careful, because I actually like this method better than this method. And we'll talk about why in just a second. I'm going to put a star here by quotient rule, because this is the tricky one. This is the one you need to be careful with. The last one we'll talk about in a minute. It's not too big a deal. The product rule is not too big a deal. The quotient rule is the tricky one. I'm going to spend a little more time on this one than I maybe would on any of the others. So let's start off with something not too crazy. Let's say I said m to the 8, n to the 5th over m to the 9, n squared. All right? So right off the bat, you can see how this could be a problem. 8 minus 9 is negative. 8 minus 9 is -1. And you don't want to deal with negative exponents. You can say that this is m to the -1, but I would really, really, really strongly suggest you don't do that. Think about the m's. There's 1, 2, 3, 4, 5, 6, 7, 8 on top. I'm just representing them with dots. There's 1, 2, 3, 4, 5, 6, 7, 8, 9 on the bottom. If you had to, start canceling them out and tell me how many's left. Well, 1, right? But it's on the bottom. And this is where the quotient rule gets tricky. Because if you just said 8 minus 9, that's -1. Now you're getting into negative exponents, and negative exponents go into the bottom, and sometimes they go to the top. And that's for homework 9. You don't want to deal with that too early. That's what makes this get a lot more complicated. Once we get into homework 9, it's not a long lecture because it's only one rule. But when these exponents get negative, it gets very complicated, or it can get very complicated. So I strongly suggest if you go to subtract and you said 8 minus 9, well, that's -1, just back off of that and think about them canceling out. There'd be 8 on top, there'd be 9 on the bottom. They'd cancel out. You still would get 1, but it would be left on the bottom. So one thing we like to tell students is they will still subtract. Always take the bigger one minus the smaller one, and however many's left is going to be where there were more, right? There's 9 M's on the bottom, there's 8 M's on top. You know, I don't know, imagine them like bottles falling off shelves onto each other, right? There's 8 on the top, there's 9 on the bottom. When they start falling, that one extra on the bottom doesn't have anything to knock it off, so it's gonna be there. So however you reckon it, hopefully you understand why the M is at the bottom. The N is pretty straightforward. There's 5 on top, 2 on the bottom, 5 minus 2 is 3. And it goes on top because there was more on top. So where they end up is dictated by where there are more of them. So watch out for this. This can be tricky, all right? Let's say we said -4 x to the 7th, y to the, just y, we'll just say y, over 12 x to the 3rd, y to the 4th, all right? So quotient rule says to just subtract them. We have 7 x's on top of 3 x's. 7 minus 3 is 4. Where would they be, on the top or the bottom? Well, there's 7 up here, 7. There's 3 down here, and we start canceling. So we will get, you know, 3 of them are going to cancel. There'll be 4 left up top, right? Because there was more of them up top. Here we have 1y, y to the 1st, and y to the 4th. 1 and 4, how many are going to cancel? Well, 1 will cancel, and how many will be left? 3, right? Where? On the bottom, because that's where there were more of them. And again, if you need to visualize it, do it. 1, 2, 3, 4 y's on the bottom, 1 up top. We cancel, and there's 3 left on the bottom. You can always do this if you need to. It's a little time consuming, but you can. Now I saved the numbers for last because, and again, remember, these are technically called coefficients, because these are not exponents. -4 over 12, we just reduced by 4. That becomes -1 over 3, right? Now, what will happen if I put this answer into the computer? Why, it will say what? And I'm sure you've seen this message before. Although your answer is correct, you know, it's in the wrong format. We don't put 1 in front of things. You probably already knew that, so just be careful about that. The answer would look like this. You don't want to get points for not simplifying, because that is, again, remember, we are simplifying. And if you put a 1 in front of something, it's like saying, I'm going to go to my 1 class and take my 1 set of notes and write it with my 1 pen. It's just redundant and silly, all right? We'll do a couple more examples of quotient rule because these are kind of tricky, but hopefully that makes sense to you. 7x is on top, 3 on the bottom, 7 minus 3 is 4. 1y on top, 4 on the bottom, 4 minus 1 is 3. And again, we keep them wherever there was more. And -4 over 12, that's just a fraction. You can just reduce that to -1/3. That's not an exponent. Make sure you're cool with me. We'll do a couple more examples of the quotient rule, and then we'll move on to the last rule. All right. Like I said, the quotient rule can be annoying, and it's probably the one that gives people the most trouble. Let's just jump into it and do a real ugly one, all right? Again, a real ugly one, they're all kind of the same. If you understand the last few, it doesn't matter how long they are, you're just doing the same thing for many numbers. Let's say I said -6, a to the 9th, b, c to the 2nd, over, let's do 8, a to the 4th, b to the 7th, c to the 2nd, all right? And again, the instruction here would just be simplify. I realize my writing's not great. It's when I write small numbers with a Sharpie, it's not great. So again, -6, a to the 9th, b, c squared, 8, a to the 4th, b to the 7th, c squared. So just go through each one and work it out. You have 9 a's over 4 a's, 9 over 4, 9 minus 4 is 5, and ask yourself where the a's are going to end up, at the top or the bottom. There's more a's at the top, so when we say 9 minus 4, we end up with 5 a's at the top. Actually, let me give myself a little bit more room there. 5 a's at the top. The b's, you have b on top and b to the 7th on the bottom. They're going to cancel out, but how many b's are up top? Just 1, right? So 7 minus 1 will be 6. And how many? And so there'll be 6 b's left, and where will they be? Well, on the bottom this time, because there was more b's on the bottom to start with than the top. So b to the 6th on the bottom. C squared, 2 minus 2 is 0. And what's anything to the 0? Just 1. Now be careful. It's not c to the 1. I mean, really, you probably already recognize these just cancel out. But it's because there's none of them, right? 2 c's minus 2 c's. There's 0 c's. There aren't any anymore. It's just the number 1, and 1 times anything is just itself. So anyway, 2 minus 2 is 0. They're gone. You probably recognize that. No big deal. And over here we have -6 over 8. Again, these are coefficients. This is not an exponent set. So we're just going to reduce these by 2 maybe. 2 goes into 6 3 times. 2 goes into 8 4 times, which would turn this into -3 over 4. Okay. The only other thing I'll warn you about with exponents or the quotient rule is you might end up with nothing in the top. So let's say we said something like m squared n to the 7th over m to the 4th n to the 9th. Similar to something we did a minute ago. You have 2 m's on top, 4 on the bottom. Hopefully you're getting a hang of this. How many would be left after we cancel? Just 2 of them in the bottom. You have 7 n's on top. You have 9 on the bottom. When we cancel 7 and 9, we'd have 2 left on the bottom because there's more on the bottom. Now notice I wrote the bar because they're on the bottom. Well, what must go on top? There always has to be something on top. So if you have nothing on top of a fraction, you want to put the 1 or it won't be correct. You can't leave it blank, and you can't just say it's m squared n squared. Because if you just type m squared n squared, you're implying that they are on the top. If there is no top or bottom given, the assumption is the top, and we don't write 1 on the bottom. So don't put 1 on the bottom. There's no need for that. But if everything ends up at the bottom and you have nothing on the top, make sure that you have a 1 up there to compensate, because we have to, think about it. If you wanted to write the number 1/2, you don't write it as blank over 2. You know what I'm saying? You have to put the 1 up there. This just doesn't make any sense. So just be careful. The quotient rule is a little tricky. Slow down and take those ones seriously. And like I said, I'll give you a worksheet next week or something to give you a little bit of practice on the stuff that'll show up on the test. All right? Let's go ahead and move on to the last of the rules here, the product rule. Or excuse me, we already did the product rule. We've done the product rule, the quotient rule, and now we'll go ahead and do the third rule, which is the power rule. All right? The third rule is the power rule. So we already asked, well, what happens if we multiply things with exponents? Well, the exponents will add. What happens if we subtract things, or excuse me, if we divide things with exponents? Well, they're going to subtract. The power rule says, okay, that's all great, but what happens if you take something with an exponent and you raise it up to another exponent? So in this case, you probably already figured out, it's going to multiply. This will be x to the 4 times 5, which is x to the 20. Again, you don't need to show the middle step. I'm just simply giving you an illustration of what's happening there. It's x to the 4 times 5, which is 20. So power rule is nice and straightforward. You have a power, you raise it to another power, they're going to multiply, no big deal. It doesn't matter how many of them there are. If I said a squared, b to the 5th, and I raised it up to the 3rd power, also known as cubed, 2 times 3, that's going to be a to the 6th. 5 times 3, that's going to be b to the 15. Right? No big deal at all. Power rule, probably the most straightforward out of the 3, to be quite honest with you. If there's coefficients, you have to be a little bit more careful. If I said -2xy to the 4th, and I said, let's go ahead and square the whole thing or raise it to the 2nd power. What power is on the x right now? I like to start with the variables first, if you hadn't noticed. What power is on the x right now? Well, a 1. So 1 times 2, that's going to be x to the 2, x squared. Power 4 on the y, 4 times 2, that's going to be y to the 8. And here, be careful, the negative is in the parenthesis, so they are included together. -2 times -2 is +4. Okay, so no big deal there. So the only thing I'll really caution you about is getting the, well, which 2 rules would you think are the ones that get the most mixed up? The product, the quotient, and the product and the power, or the quotient and the power? You probably already know it's the power and the product, because the names are similar, right? Be careful that you get these straight. The product rule says if you're multiplying, you add. The power rule says if you raise a power to another power, they're going to multiply. Be careful that you keep these straight. There's a couple of questions at the end of the homework where they combine the problems. Nothing crazy, really. Something like this, maybe. So here we'd have like -3 x squared over x to the 5th, and it's all raised up to the 3rd. We'll think about order of operations, and we'll actually do another order of operations problem in a minute, because those are something you guys seem to have. You seem to like to email me about those, so we'll go ahead and just do one in the homework or in the lecture. What would order of operations tell you to do first here? Not exponents, right? What comes before you do exponents in order of operations? Parentheses. So we're going to do what's inside the parentheses first and combine the x's. So what we're going to have here is -3. There's 2 x's on top. There's 5 x's on the bottom. So they're going to cancel. 5 minus 2 is 3. And they're going to be on the bottom because that's how many x's there were down there. So be careful. There's 3's all over the place, yeah? So in the inside now we have -3 over x to the third, and that was the quotient rule. That's what just happened there. We just did the quotient rule. Now on the next step, which I'm gonna have to do over here, we're going to do the power rule, right? Because now we have things raised up to a power to a power. So let's go ahead and just move this over here. -3 to the third, and the negative is in the parentheses. So -3 times -3 times -3. That's -27. On the bottom, we have x to the third and raised to the third. Well, we just said a power to a power, 3 to the 3. You multiply, and that would be x to the 9. So take a minute, make sure that makes sense to you. And that wraps us up with the 3 rules: product rule, power rule, quotient rule. Remember, the rule names tell you when to use them, not what the rule does. That's the part that gets everybody confused. All right? Let's go ahead and wrap this up with an order of operations problem. You already know the order of operations. We've talked about this several times. We just haven't used the exponents in order of operations yet. So hopefully you already know the order. Let's go over that real quick. First step is grouping symbols. Again, you know, PEMDAS, whatever, I guess, if you want. Grouping symbols, though, parentheses, brackets, braces, all that kind of stuff. Second step, which we've been skipping up to now, is exponents and roots. And I would ask you in PEMDAS where your square roots are. And remember, if they occur at the same time, exponents and roots, just like multiplication and division, they're on the same step, right? Which one comes first? We do them what? Left to right. And then, of course, addition and subtraction last. So let's take a look at a homework problem. I'm actually just gonna, I mean, it's kind of a waste, but I'm gonna go ahead and get another sheet of paper because it's kind of big. I don't want to run out. So make sure you have your order of operations written down. We'll go ahead and just do this on another sheet of paper. And this will wrap us up. This one is directly out of the homework. I picked the ugliest one, or the one I thought was the ugliest. I mean, you guys, of course, might disagree, but I took the ugliest one. Hopefully that'll help ease your burden a little bit. I actually don't know what number this was. I didn't write it down. Apologies about that. But again, they're randomized to some extent, so it's unlikely you're going to get the exact same one in your homework anyway. You should get something similar to this, though. All right, so quite a mess here. So what we have on top, we have negative outside the big bracket, -8 minus inside the parenthesis, 5 minus 10, and then that's squared. All of that is over a big bracket, 20 divided by 5 in parentheses plus 4. All of that in that bracket is squared, minus 62 over 2. So the first thing we do in order of operations is parentheses is grouping symbols, right? Now the trick here, and the reason I picked this one, is there's a grouping symbol here that they're not writing. There's actually a big parenthesis around the numerator and a big parenthesis around the denominator. Now I'm not going to leave those there because it's ugly looking, but you should be aware of that, which means you need to do one and then the other, and then divide them out. So when you're dealing with a fraction or order of operations, you should recognize that there actually are hidden parentheses around the top and the bottom, meaning you got to work the whole top out, get whatever that is. You got to work the whole bottom out, get whatever that is, and then do the division. Which one you do first doesn't really matter because they're not left or right. They're just sitting on top of each other, so we'll do the top first. See why I used the whole sheet of paper for this, right? So there's the top. In the top, what would we do first? Well, we still have parentheses and brackets, so we would go inside the brackets. And then once we're inside the brackets, we find another set of parentheses, so that's where we'd start first. So this will be -8 minus 5 minus 10 is -5, still in the parentheses, and that's still squared. We're working inside the bracket here. So that's going to be -8. Do not multiply negative and negative. We are not multiplying yet. We still have not done the exponent. So -8 minus -5 squared. We're going to do the exponent next, which gives us 25. Again, parenthesis, now exponent. Now we can go ahead and say, well, -8 minus 25, that's -33. Don't forget that that whole thing was in the bracket. And don't forget we still had another negative. So this really comes out to be just 33. Okay? Take a minute, make sure that's clear to you. So our top came out to be 33. Now we'll go ahead and do the bottom. We had bracket and then parenthesis 20 divided by 5 plus 4, close parenthesis or close bracket squared, minus 62 over 2. So once again, now that we're in the denominator, we'll start with the grouping symbol. So we'll start inside the bracket. There's a parenthesis inside of that, so that's where we'll start first. 20 divided by 5 is 4. We still have a plus 4 inside the bracket. So 4 plus 4 is 8, and that needs to be squared. 8 squared is 64. I'm running off the room there, sorry. 64 minus, now we do division over here outside the bracket. 62 divided by 2 is 31. 64 minus 31 is 33. So we got 33 on top, we got 33 in the bottom. 33 divided by 33 is 1. So take a minute, look that over, kind of an ugly one there, kind of complicated. You'll probably want to pause. And I should wrap you up with homework 8. Be doing homework 9 next. Pay attention to details on the due dates. I'll be sending out emails on those. We got a little off schedule this semester. So yeah, work this out, guys. Make sure you're comfortable with it. Before you move on to homework 9, make sure you get homework 8 done, because homework 9 builds upon homework 8. And I will see you guys in the next one.